Welcome to B2. Today we are looking at sigma notation, unit 5.6. So sigma notation looks something like this. Often I'll just write it like this, so you'll write it quickly. It's kind of like this, almost like an E shape. Okay, and what it means is, it means sum. And then with this, what we do is we put limits on the top and the bottom to show what we're doing. So, for example, r equals 1 and 8 on the top. So if I have the sum, this would involve r. So say 3r minus 1. r equals 1 and 8. And what that means is that starting at r equals 1 and going as far as r equals 8, I would substitute into this to get my series. So substituting 1 in, we'd get 3 lots of 1 minus 1, and that's going to be 2. And then 3 lots of 2 is 6, minus 1 is 5. 3 lots of 3 is 9, minus 1, 8, and so on. You can see it's going up in threes. It is a arithmetic series here. And there I am complete. And you'll see, because of the numbers we got here, we got 1, 2, 3, 4, 5, 6, 7, 8 terms. And we'd expect that because we substituted in between 1 and 8 into here. Now all I do is add this up, which in this case would give me 100. Now, obviously, looking at this, I wouldn't necessarily always write these all out, because if I have a bigger value here, that would be huge. And that's where I start to use my formulae from previously. So like in this one, we would have known that a equals 2, work out the first term. We know our common difference here is 3, and we know that n equals 8. So we could find the sum to 8 terms. So we got n over 2, and we got 2a plus n minus 1 t. Another one we could do is using Sn n over 2 a plus l, the last term. So again, 8 over 2, and that is going to be 2 for a and 23 for l. And again, of course, that equals 100. Now, if it is an arithmetic series, then once I know what d is, obviously I'd substitute in the first term to get the first term, and then I would just substitute in and find the last term, and I would use this formula. Okay, and that would always make my life a lot easier and make me finding these a lot quicker and more efficient. Okay, but you do need to be careful, because using the sigma notation, it just means sum. So this can apply to both arithmetic and geometric. Now, of course, it's not always going to be arithmetic, so we'll take a look at a geometric one. So we could have something like this. And if I work this out, we've got substituting r equals 1, so we've got 5 times 3, which is 15. Then we've got 5 times 9, which is 45. Then 5 times 27, 135. Then 5 times 81. And finally 5 times 243. And there's my series. So what you will notice is that This is a geometric series. A is 15. If I look at R, so we take two terms, you can see that R is 3, and I'll just check with another term, so 135 over 45, and we still get 3. Number of terms I've got is 5. So again, I can use the formula for geometric series. Like so, so we just get 15, 3 to the power 5 minus 1 over 5 minus 1. Sorry, not 5, what am I doing there? R is 3, 3 minus 1. That gives me 1,815 in my calculator. And again, if I check by actually adding these values up, I get exactly the same answer. Okay, so what I would say is that it's not always obvious which one's a geometric, which one's an arithmetic when you first start out. Hopefully, as you do more and more of these, you will start to see a pattern and you'll be able to spot which ones are arithmetic and which ones are geometric. Now, additionally, we will be looking at other series called recurrence relations, and again the sigma notation can show up in those types of sequences. So first example here, let's start by substituting R equals 1 in. So we get 5 lots of 1 plus 3 is 8. Substitute 2 in. 5 lots of 2 is 10, plus 3, 13. Let's do another one. 5 lots of 3 is 15, plus 3 is 18. So you can see here that it is an arithmetic series. It's going up in 5s. And what I want to do is find that last term. 5 times 30 is 150, plus 3, 153. So now we can see that A is 8. Now we've got D, but let's just put in our last term as 153, and N equals 30, as we have 30 terms. So sum to N terms, N over 2, and I'm going to use A plus L. So 30 over 2, and we've got 8 plus 153. And our sum is 2415. Now, what I would say is, just before I do go on to the next example, if you've got a large number of terms in your sequence, like in this one 30, using the sum formula will be the quickest. If you know the number of terms, this formula, A plus L, will be your most efficient method. If you've only got like 4 or 5 terms, it's probably quicker to work out those terms, like if it's 4 terms or 5 terms, and just actually add them together without using your formula. And here's a perfect example of that. So substituted in our value, so we got 3 to the power 1 plus 1 is 4. 3 squared is 9, plus 1 is 10. 3 cubed is 27, plus 1 is 28. And 3 to the power 4 is 81, plus 1 is 82. And all I want to do is add these values together, and I get 124. And this particular one wasn't an arithmetic sequence, or series I should say, or a geometric one there. But it's just a nice example just to show you, if you've got a small value of n, of a small number of terms, it's just much quicker to work out each term. Now let's have a look at this one. So we've got between 1 and 12, and here's our series. So the first term here, we got 4 times 7. So it's going to be 28. If I look at the next one now, we got 4 times 7 squared, 196, 4 times 7 cubed, 1372. These are going up pretty quickly. But luckily I don't need to find them all. So let's find R first of all. 196 over 28. And I get 7. And if I check this one as well, 1372 over 196, I also get 7. You want to do at least 2 to double check to make sure that it is a geometric series. We've got 12 terms, and our first term is 28. Now, with R being greater than 1, in this case then we would use, it's easier to use R to the power n minus 1 way around. So we got 28, 7 to the power, so we're looking at 12 terms. Now this is actually quite a big answer, so I'll leave it in standard form. Like so. But just an example, very quick example of a geometric series. Now, in this example, you can see we don't start at 1. So R equals 10 to 20 are our limits. So substituting 10 in for our first one, we have 5 times 10 is 50, take away 7 is 43. Then we've got 5 times 11 is 55, take away 7 is 48. 5 12 60, take away 7, 53, and so on. And then for the last term, 5 times 20, take away 7, gives me 93. So that means that A is 43, and my last term is 93. Now, it's the value of n on this type of question where people go wrong. So in this case, n is 11. Okay, and what people often do is they quickly go, right, well, 20 take away 10 is 10. So n is 10, but that's not true. If we applied that very same logic to this kind of question, we'd be going 10 take away 1 is 9. And obviously we don't do that. So that kind of logic doesn't make any sense. The best way of thinking of it is that in this case, 1 to 9 is what we don't want. So we're actually taking away 9 values from my 20. Okay, so that is 20 minus 9, which is 11. If in doubt, just count it up with your fingers if you have to. Anyway, let's get into this. So Sn is n over 2 a plus l. Like I said, I prefer to use a plus l if I know the value of n and everything. So sum to 11 terms. So we got 11 over 2, 43 plus 93. And that gives me 748. Now, for this kind of sequence here, we've got R from R is 1 up to n to R. So I think the first term would be substituting 1 in, so that's 2. Then 2 in is 4. Then 3 in is 6. And so on. The final term is substituting n in, so there's 2n. So we can see that a equals 2. Our common difference is 2, but we won't be using that. As we can see, our last term is 2n. And n, number of terms, is obviously n. So sum to n terms, we got n over 2 a plus l. So n over 2, now a is 2 and l is 2n. So n over 2 times 2 is just n, and n over 2 times 2n is n squared. So now we have proved it. Very straightforward. Okay, 6 questions for you to try here. As always, I put the answers at the end. Don't forget to like and subscribe. especially if you haven't subscribed so far. Pause the video now, give yourself a little bit of time. Now, for this one, I've purposely chosen the same as the one before, but with a different starting point. And what that means is it allows us to do it in two different ways. We can do it as we've done before, starting at r equals 15, going up to the 25 as normal. But as an alternative method, what we can do is we can look at what we had as a total between 1 and 25. And we can take away between 1 and 14. So what we're able to do here is we can use our answer to D in this part, and then we can just work out this part, which is just between 1 and 14, for this, and then subtract them. Now, where that makes our life a little bit easier is because to work this out, I've still got the same A value, I've still got the same R value. All I need to do is adjust my N value. Whereas if I'm going between R is 15 and R is 25, I've got to create my new A value. R should be the same, but obviously if I was doing it from scratch, I'd be looking at that and work out my N value. So if you've already got part of a question where these two are kind of linked, it can make your life a little bit easier. So we got our answer to part D minus, and then I just need to work out this one. So if you think of S of 14, and this is going to be 3 over 2, 1 minus a half to the power 14 over 1 minus a half. And that then gives me a very strange number, but it's very close. I'm going to write down the full value. Didn't choose very nice values here, but to 3 significant figures. Okay, didn't choose the best values for this particular example, but hopefully you get the idea of being able to use a separate method to help you make your life a little bit easier. Now, for question part B, we've got a little bit more of a challenging one, because if I start substituting 1 into here, I'm actually not going to get a geometric or an arithmetic series. So actually what I want to do is think of splitting this up. So I can split this up into the sum of 2 to the power r minus the sum of 12r. And doing it this way is going to give me two series where one is geometric and one is arithmetic. So let's do our geometric one first. When I substitute 1 in, I get 2. Substitute 2 in, I get 4. Substitute 3 in, I get 8, and so on. So a is 2. The common ratio here is also 2, going up by multiplying 2's, and n is 15. So sum to n terms, remember, is a rn minus 1 over r minus 1, 2 to the power 15 minus 1 over 2 minus 1. Remember, you're always writing down your formula at the start, as the more practice questions you do where you're writing the formula down, the more it will stay in your head. So that's my first bit. Next, I want to find the sum of the other sequence or series. Now this one's going to be a arithmetic series. So substitute 1 in, we get 12, substitute 2 in, we get 24, 3 in, we get 36, and so on. You can see it's got a common difference here of 12. Now, I want to find the last term, so 12 times 15 is 180, as this is much easier to work out when I have the first and last terms, and of course n is still 15. So continuing on, we've got the sum to n terms here, so this is going to be n over 2a plus l. So again, sum to 15 terms, it's going to be 15 over 2, a is 12 and l is 180. That will give me 1440. So now what we've got is just need to take these away. So we can say that if I write it out in full now, 2r minus 12r. So this is, as we were saying, 2 to the power r minus the 12r. So that is 65534 minus 1440. And we get our 64094 as required here. Now this splitting these up can come in very much handy as you go along, so you can always split them up in terms of like a minus or a plus. You can also actually split them up with multiplied, but I wouldn't worry about that for P2. Those of you doing FP1 will see that they'll have slightly other methods that they can use to help solve these as well. Now, with this bit, obviously we could work this out from scratch, hence the or otherwise bit. Work out my first few terms and so on. But if we do what it's asked us to do, use your answer to part A, then that can make this a little bit easier. So if you think part A was the sum of 1 to 30 from 4R, in this one, my sequence is the same, but each term has an extra 1 added to it. So like if I look at this one, instead of 4, I'd have 5, instead of 8, I'd have 9, instead of 12, I'd have 13, and so on. So that means there's an extra 1 being added to each term. There's 30 terms in my sequence, or my series, so I need to add an extra 30. Yeah, so this is essentially, if I split this up to 4R plus the sum of that 1, so 30 lots of 1. So that gives me 1,860 plus 30, so 1,890. Now, if I look at this one, I can do something similar. Okay, you can see the 8R means it's going to be double this. That's 4R. It's going to be 2 lots of 4R each time, so each answer is doubled, so my overall sum is double. And then again, we're going to take 5 away from each of them. So if I do 30 lots of 5 and then take that away, that should give me my overall value. So for this one, I'm going to write it out like this. Hopefully this will help you in the future. So we got 2 lots of this one, it's 4R minus, and then this sum when it's 5. Okay, so we get 2 lots of 1,860 minus basically 5 lots of 30. Okay, another way I could write this is it's 5 lots of that sum of 1s. Okay, sum of 1s is 30. In this case, 5 lots of 30. A couple of ways of doing it there. And that gives me 3570. Now, I haven't mentioned it up until this point, but these types of questions you can check your final answer with on your calculator. So sorry about the shaky camera here. So if I press shift and this button, you can see I get a sum of. So if I do this final question here, so we'd have 8x instead of r minus 5, and then I've got it between 1 and 30, and you can see there 3570, which is what we had. And this will make your life a little bit easier. Okay, you'll still need to show all you're working out, but you can use the calculator method, just this bit here. You can use this to help you check your answers as you go along.